Right, this is Miss Steele's Algebra 2. It's going to be a short review of Chapter 10. This first video is going to be dealing with classifying conics. I know this is something that a lot of people struggle with, so let's just briefly go over this. So if we have a circle, it's always in the form x minus h squared plus y minus k squared equals r squared, where hk is the center. So the ordered pair HK is the center. Since the circle is the same, no matter how you turn it, the horizontal axis and vertical axis remain the same for a circle. For a parabola, the H and K represent the vertex. And a parabola is the only conic that only has one squared term. So notice in your formulas, there's only one squared term for each. If we have a horizontal axis would be the x-axis, so our x value is going to be the variable without a square term. And if we have a vertical parabola, then our y value will be the variable without a square term. So horizontal, our parabola could open left or right. If our p-value is negative, then we know that it opens left. If our p-value is positive, then it opens right. So for horizontal, if p is less than 0, opens left, and if p is greater than 0, we know it opens right. If we have a vertical parabola, then we know that if p is less than 0, our parabola will open down. And if p is greater than 0, the parabola opens up. Again, it's just very important to be sure that the k value always belongs with the y and the h value always belongs with the x, no matter where the squared term is. So next, let's talk about an ellipse for a little bit. Ellipses, the biggest thing to remember is that there's a plus in between. A good way to remember that is because when you graph a circle, or when you graph an ellipse, it looks very similar to a circle. Circles have a plus, so ellipses also have a plus because they look very similar when you graph them. Again, the HK represents the center of the ellipse. So the HK represents the center of the ellipse. Since both terms are positive, the x term and y term can always stay in the same spot. The numerators do not change. However, it's all based on your a value and your a and your b value. Since our a value is always bigger, a is always bigger than b, we always want to look at where our a value is located, where the bigger which term has the bigger denominator. If the a is underneath the x term, then it's horizontal because x-axis is horizontal. If the bigger denominator is underneath the y term, then think y-axis is vertical. So we're going to have a vertical ellipse. And then next we're talking about hyperbolas. The biggest difference between ellipses and hyperbolas is that minus sign. Again, that HK represents the center. And in this case, A does not have to be bigger than B. So A does not have to be bigger than B. In fact, the denominators A and B, they're always going to be in that spot. So the first term, the positive term, will always have the denominator of A squared, and the second term will always have the denominator of b squared. We are looking at which term comes first. So if we have horizontal, our x term is going to come first. So the positive term will be the x term. Think x term x-axis, x-axis horizontal. For a vertical hyperbola, that y term is going to be the positive term. So anytime we're dealing with hyperbolas, we're just looking at what term is positive, whether it be the x term or the y term. That's how we know whether it's vertical or horizontal. So let's write down a couple examples of how to classify conics. If I have, say, 2x squared plus 2y squared minus 5x plus 4y minus 2 equals 0, something we're going to be looking at is the coefficients in front of the x squared term and the y squared term. Since they are both the same, that means that we have a circle. If we have 2x squared minus 3y squared, then we can leave everything else the same. Again, we're just going to be looking at the coefficients out in front of the x squared term and the y squared term. We have a 2 and a 3. Since they're not the same, that tells us that we're either going to have an ellipse or we're going to have a hyperbola. The way we know is if they both have the same sign. So if they're both positive, then it's going to be an ellipse. But if we have one positive and one negative, then it's going to be a hyperbola. So we can go ahead and circle hyperbola and cross out ellipse. Another example, if these were just 2x squared plus 3y squared and everything else was the same, since these are not the same number, but they have the same sign, that tells us we'd have an ellipse. Okay, and then last but not least, if we have any function or any polynomial, say 2x squared minus 2y plus 2x minus 3 equals 0. Notice that I only have one squared term. This 2x squared is my only squared term. Whether it be a y squared or an x squared term, this tells us that we're going to have a parabola. Parabolas should be the easiest ones to point out just because they're the only ones with only one squared term.